people are starting to say, well, maybe I don't need to store all that energy. Maybe if I could just put it down and charge it in 15 seconds, I could get by with a 2-hour battery life.
So Dan, welcome to the Drive for Innovation.
Thank you.
Thanks for taking the time. So InHand Technologies, tell us about the company, because it's new to me.
Okay, so the company's been around since 2000 as InHand Electronics. We focus on small form factor, battery-operated devices, things that would go inside military, medical, or industrial type handheld products where low power or battery-backed operation is important to the particular user. We focus on primarily ARM processors and Atom, so low power processors. We don't do any of the high-end processors. And then we focus on operating systems similar to Windows XP, Windows Embedded, Compact, Linux, Android.
The precursor to this company started in '84. What was it always a low power focus, or did that take off with sort of the evolution of ARM and the whole microelectronics push into better power management?
So in the beginning, it focused on pretty much anything that DARPA needed. We focused on research that was generated through military needs or DARPA efforts. And towards the latter part of the 90s, there was a lot of focus on power management with them, and things like that we take for granted today, things like dynamic voltage and frequency scaling, didn't exist in processors back then. So some of our patents in that area, called Battery Smart, revolved around doing exactly that, dynamically changing the voltage of a system and changing the frequency in order to reduce your power consumption and sort of tailor it to what the device is doing at the time, instead of always running at a high level or always running at a low level.
So let's talk a little bit about that. Obviously ARM has risen to the challenge over the last 15 years or so. The Atom processor is trying to do the same thing. You're obviously at the cutting edge of power management. You talked about dynamic power management. What's just on the other side of the corner? What's just around the bend in terms of new techniques that are starting to be used to squeeze even more power management savings?
Well, some of the techniques that are out there, and it's sort of things that are in research and the things that are definitely going to impact the mobile space. People are working on microcapacitors, which will give you fast charge capabilities. So instead of focusing on giving a battery life of 10, 12, 15 hours, people are starting to say, well, maybe I don't need to store all that energy. Maybe if I could just put it down and charge it in 15 seconds, I could get by with a 2-hour battery life. And so that's where the concept of going to very, very small form factor capacitors and putting them in parallel and many of them in a system and just essentially setting it on there and quickly charging it up, that's helping out. Some of the areas that are also helping handhelds are lower power batteries, lower power displays, things transflective. There's some new displays out there that go into a reflective mode when the ambient light is too great, and so they go into a reflective mode, reduces the color spectrum, but it still gives somebody the visibility if they're in full sunlight to see their display and the content. Other things are obviously in the processor world, it's nanometer processor, process, get that down, get the overall power consumption of the chip down, and then start focusing on the peripheral. So there's people looking at being more conscious about what the system is doing, and so they'll turn off radios, and instead of always sending data, if you think of an M2M system, a machine-to-machine system, instead of always sending data when the application says I have this data that I need to send to the server, they might cache that for an hour, 2 hours, and wait for a bunch of aggregate messages to come along, fire up the radio, since in an M2M system that would be the bulk of the power consumption would be while it's transmitting, fire that up for a brief period of time, send much more data than they would if they were sending individual datagrams from an application, and then going back down to sleep and turning off the radio. So we're starting to see a more holistic approach to what the device is doing and not just what each individual IC is doing.
One of my big hobby horses is piezoelectric power generation. And in the mobile space, you know, you're always moving around, things are vibrating all the time. What, are we anywhere closer to more intelligently harvesting that kind of energy?
You know, it's an area that comes up. People are obviously looking at it. It hasn't seen a big breakthrough. People are right now, they're focusing on sort of the other sides of the equation versus that power generation. I mean, the power generation side, they're focusing on power cells and some of these other mechanisms, partly because my guess is that the energy you can generate, we're still not where we could run a whole handheld or an Atom processor off of the motion that we capture back from a human.
Are there, on the processor front, you mentioned Atom, you mentioned ARM, are there any others? I mean, there are others that seem to have fallen by the wayside, at least in terms of power management, MIPS and some others. Are there any sort of up-and-comers out there that you're starting to evaluate?
None that we're evaluating. There's the traditional ARM, and now we've got Atom. And then what we're seeing is that in order to reduce the power consumption of these SoCs even more, they're focusing on what I call, they're populating ASICs into here. So there's portions of the chip that are dedicated to H.264 encode and decode. So they're offloading the ARM and they're getting it down into what I consider to be almost an ASIC, and then that's helping them lower the power consumption more.
Now, when you're working on a system and you make a trade-off between ARM and Atom, what are the motivations behind that? Do you use Atom for certain kinds of applications and ARM for others?
In general, for us, it's a lot of times it's customer driven. So we do off-the-shelf products as well as customizations of electronics for particular OEMs. And most of the time, that's the decision between Atom and ARM is made by our customer, and it generally falls around software that they have to run on. So if you look at an industrial application or a military application, they've got or I should say military system, industrial system, they have applications, software applications that they've been running for years in a warehouse or in a battalion or what have you. And the concept of recompiling that, recertifying it, and moving it to an architecture that's different than what it's already on, that is not something that most customers are able to do in a cost-effective manner. So if they've been running it on a netbook or a laptop, and they come in and now they want it on a handheld running a lower power system, they're going to come in and be on Atom. If they've been running it on an ARM, let's say an old HP or a compact type PDA, they're going to come in and generally want that to be on an ARM platform.
Okay. So you have some boards. You have an evaluation kit here. Tell us what kind of eye candy we have here.
So in general, all of our boards are small form factor. So this is a new TI-OMAP or DaVinci DM3730 board. It's a full working motherboard. It's targeted to be what you would put inside a cell phone. So it's got all the interfaces you would need in a cell phone. It's got a micro USB port, real-time battery clock, all the inputs and outputs for a very specialized device. It has connectivity for the display and for a battery, and then that's pretty much it. But for our industrial customers or for folks designing, let's say, tablets or special function handhelds, we have to give the ability to expand it, and that's what these two connectors on the back do. They provide typical interfaces like USB, SPI, I2C, SM bus, GPIOs. They provide all the capabilities that a customer would need to design a system specifically for what they're going into, whether that be a tractor monitoring system for a particular tractor, whether it be an industrial automation system, what have you. They can plop this down. All the software drivers are done for them, and they sort of just go to town working on the application. And that's sort of what is in this system here. So we've got a little handheld demo that has this board in it. In the back, it's just the board, the battery, and a display. And it's basically meant to sort of mock up what you would do if you were just building a small single function handheld.
Right. Okay.
Here. This is our Atom-based board and development kit. So this is what our customers would start developing their software on from day one while they were wrapping plastics or metal around the particular board. This is also a full working motherboard with expansion capability. All of our systems are meant to be expanded on, but they're also meant to be utilized by themselves. which sort of makes them a hybrid in this world, because a lot of people in the Atom world, you get a motherboard that has no expansion capability other than PCI slots, or you get a comms module which doesn't work on its own at all. It sits there, and you have to design a board to work with it. This is sort of a hybrid, and we have a lot of customers that take this product and sort of just throw it into an enclosure and utilize it as is. And so that's what's driving this. There's nothing but this, and there is a Wi-Fi module, Wi-Fi, Bluetooth, and GPS module on here. And this demo is running Windows 8. So we were able to take the Windows 8 Community Development Edition and just put it right on the hardware.
So you're CTO. What's your biggest engineering challenge these days?
Most of the time, it's just the speed at which everything is moving. And in this world, in the industrial and military world, it used to be that customers would wait. You know, they understood that what they're seeing in the consumer world, they're not going to have for 3, 4, 5 years. Today, though, that's not the case. You know, I was at CES in January, and I'm standing next to a colonel, or a general. It was actually a general in the Army, and he's looking at these tablet computers. And so I just casually asked him, you know, is that something you think you could deploy? And he says, you know, we're thinking about it because we're getting tired of waiting for the ruggedized version. They're almost to the point where they'd rather take a consumer product and get it out there faster than wait for people to slowly come out with the latest and greatest. And that's sort of, if you look across the, let's say, the industrial handheld market, most of the handhelds that are sold by some of our customers and even by some of our customers' competitors, they're all focused around PXA 270 chips, which those were brand new in about 2004.
Yeah.
And that's I would think that the bulk of what's being shipped in a industrial handheld space is coming out with 270 systems.
Well, it completely blew me away about 10 years ago when the military started going to COTS, you know, and that took a long time. And so I get the feeling that their adoption rate for off-the-shelf stuff is just quickening with each year, just to your point, that they see the stuff, they're using it in their personal lives.
Right.
Why not use it in military applications?
Yeah, and the soldiers that are coming out now are younger, more savvy. They're picking up the technology, and they're almost demanding that technology. And you hand them this handheld that doesn't have a touchscreen on it. It's got all these keypads, and they go to use the touchscreen, and they almost get frustrated when they're trying to utilize it.
So that's on the military side. You also sell into the industrial space?
The industrial and the medical. So pretty much anywhere that has very stringent performance requirements and long life capabilities. We specialize even on our off-the-shelf products on making sure that what we build today we'll be able to build 5 and 7 years from now, so that they can get the device deployed, certified for its use, and then not have to worry about it. So those are the 3 markets that we do tend to focus on.
So let's talk about medical a little bit. Is security the biggest deal for them there, or is it other things like cost and connectivity, you know?
Well, all of them are, you know, you can't really, the customers don't typically walk in with just one thing anymore. Right. So it's all of them. Security is always key. For the most part, what we see, just because of the types of devices we make, is battery life. You know, there's a lot of handhelds on the market and a lot of products that last 6 hours, which for a nurse on an 8-hour or 12-hour shift is about as worthless as it can be. So they really, in much of these deployment scenarios, they really want the battery life. They want to be able to use the device and utilize it for a whole shift. So we see a lot of people focus on that, but obviously things like security, connectivity, those are sort of table stakes. The device has to have the basic minimum for it to even be considered.
Cool. Good stuff.